Okay, so today with 2.4, we're talking about, can you graph a system or group of equations or inequalities, a system, and find out, is there a solution that works for everybody? Okay, and we talk about that in real life, and we'll go further with that this year than you've gone before, but normally you solve systems of equations, especially if they're linear, by graphing and seeing if there's a common point where they overlap, or if you're graphing inequalities, you look for a common region or group of points that would overlap. Another way to do it is going to be substitution, where you literally substitute one equation into another to help figure out, hey, can we find a solution that works for both? Or you add the two equations together to mesh them together to find a common solution for that system as well. So we're looking for an ordered pair at this point. To see what would work for both of these things. And so, as we look at these problems, not all lines cross, parallel lines don't. So we're going to be talking about the vocabulary because this is going to be something that is important to not just be able to find answers, be able to talk about what we're doing. Okay, sound as smart as you are. Okay, so if you graph most lines, you'll notice unless they have the same slope, they're going to cross one time. Okay, all lines that aren't parallel will cross each other. So if you've got a group of equations, a system of equations, we'll focus on starting with two equations now. You can get higher and get more than that and be like, hey, is there something that satisfies all these parameters or solutions or equations that you come up with? And so if your lines will cross, we'll say that there's a consistency, there's an answer. If you're like a food critic, you're like, what's the consistency of this, this beautiful sauce? Okay, consistent, that means there's something there to look at. So there's a solution. So if something is consistent, that means that the two lines or the multiple lines will have a point or multiple points that make it true. And so this point right here is where they cross. That point is common to both lines. It works for both. If you graph the same line twice, notice they have a lot of points in common, don't they? They don't just have one. They have all of their points in common. That doesn't mean every point in America, in the whole world, the whole ordered pair system works, coordinate system works. But it means every point on the first line will also work on the second because they're the same line. Okay, so if there's a solution, we call it consistent. If it is one solution, one ordered pair solution, look at the word independent. It kind of looks like it starts with the number 1. Independent means that there's one ordered pair solution. Okay, it's an X by team. If there is dump a whole bunch, that's my D, dump a whole bunch of solutions, dependent means there's a lot of solutions that make both equations true. Okay. And then if there's nothing there, it's inconsistent. That means there's no solution that works for both because they're parallel. Okay, and so what I would say is these first couple equations, they don't actually want you to find the answers, which is a valid question to ask, but instead they say, can you just name the system? How many solutions will there be? And based upon how many solutions in common between the equations, what would you characterize that to be? And so what we would say is that if we don't want to actually find the answers, a very cool, easy way to do it is to examine the equations and look and see, do they have the same slope? Are they parallel? Or do they have different slopes where they're going to cross? Okay. So any line that's not parallel or the same is going to cross just once. And so if you get this into y equals mx plus b, so minus 2x from both sides, you get negative y is equal to negative 2x plus 18. Divide everybody by negative 1, y is equal to 2x minus 18. You're going to get the first equation. The next one, if you minus 3x from both sides, and then you get 2y equals, what's it do? Negative 3x plus 10, divide everybody by 2, you're going to get y is equal to negative 3 halves x plus 10 over 2, which is 5. And so if you look at that, and even if you graphed it, you would notice, hey, these two lines don't have the same slope. They're going to cross. One's going to truck uphill from negative 18. The other one's going to start at 5 and truck on downhill. Any lines that aren't parallel will cross each other one time. And so we would say, hey, there's going to be a point of intersection. So it's going to be consistent. There's something to talk about. Okay. And it's also going to be one ordered pair. So you call it independent. Okay, definitely spelled that wrong, but I tried to put a 1 and then independent. So consistent and independent would be the two words you would put with it. The second one, if you look at it and say, okay, well, let's get them into y equals mx plus b, you could literally solve them, but it's much easier and more efficient if you just get them into slope intercept form and say, hey, if you were to graph them, what would you notice? Divide everybody by negative 4, so y is equal to, if you divide negative by negative, remember you get positive. So y is equal to 1/2 x and then minus 2. Okay, cute. And then the next one, if you add 3x to both sides, you get 6y is equal to 3x plus 12. Divide everybody by 6, and you get y is equal to 1/2 x plus 2. Now notice, if you got the same exact equation, they'd have a whole lot in common. So be careful of your signs, okay? So these have the same slope and different y-intercepts, so they're going to be parallel, so that means there's no solution. And so you could write no solution, but if they said give it a vocabulary word, you would say it's inconsistent. Again, remember, if you got the same exact equation twice over, that means when you graphed both the lines, they would make a sandwich, okay? They would be the same exact line graphed on top of each other, and they'd have infinitely many points in common, and you'd write consistent and dependent, just like this second example right here. Okay, so you should study your vocabulary. The next part is, hey, how do you actually go about solving these equations? And if you notice, these are some short notes. We're going to solve them by graphing them. Okay, the important thing is graph them and be very careful to apply the slope in both directions until the graphs specifically and characteristically appropriately meet. Okay, that's a lot of adjectives, or adverbs, but be very careful that you do that. And so if you minus 4x from both sides, you're going to get negative, oops, I need a pen. Negative y is equal to negative 4x plus 5. If you divide everybody by negative 1, you get y is equal to 4x minus 5. So be careful that you get these into slope-intercept form as appropriate. And so if we start at negative 5, 1, 2, 3, 4, 5, count carefully, then do the slope. It's up 4 over 1, and then up 4 over 1, and apply the slope religiously. 1, 2, 3, 4 over 1 until they will intersect. So the next one would be y is equal to negative 2x plus 7. So if you start at 7, I'm going to start with green up here. So 7, 1, 2, 3. And then what they want you to do, oops, I guess that's not green. Start at 7, go down 2 and over 1, down 2 and over 1. It looks like this is the ordered pair. And I always circle when they meet, because it's easy to miscount and forget and struggle. You should draw a line between these two things, but most importantly is to find out, can you apply the slope carefully and appropriately? The ordered pair is going to be 3, 2, and name it. When x is 3 and y is 2, that should work. And so you can always check it, plug it into both equations, see if you plug in x is 2, 3, and y is 2 into both equations, is that a common solution for both problems? And you should draw arrows on your lines, blah, blah, blah stuff. There you go. Okay. The next one, if you get it into y equals mx plus b, you minus 6x from both sides. And so that would be consistent and independent. So negative 3y is equal to negative 6x plus 15. Divide by negative 3, you get y is equal to 2x minus 5. So 2x minus 5. And so if you start at negative 5, 1, 2, 3, 4, 5, and you go up 2 and over 1, and you got to go until they'll meet. So you may want to do quite a few depending. Okay, you can always go back and keep doing the slope. The other one is the exact same line. So when I graph that, and even if I do a different color, guess how many points are going to be in common? All of them. So therefore, what's the answer? Infinitely many solutions. So if you were characterizing it, if you're saying, what's the answer? Well, all the points that are on this line will also be on the other line. Okay, every point that makes this true will make the other one true. And then also if you gave it vocabulary, you'd say consistent and dependent, dump a whole bunch in, okay? And then the last one, let's see, if you start at negative 1 and you go down 2 and over 1, and you can also backtrack up 2 and over 1, up 2 and over 1. And then the other one is y is equal to negative x plus 1. I'm going to pick another color. Let's do blue. Starting at 1, you go down 1 over 1. Oh dear, this is a tricky one, because you got to be real careful so you figure out exactly where they meet, okay? And it looks like they meet at negative 3, negative 2, 3. And you should draw the lines, and I'm on a computer, so it's not going to look very pretty, but I think the most important thing is really be careful with how you apply the slopes. You're not just drawing 2 points, extending the lines and trying to like guesstimate where that's going to happen. I think the next thing is we're going to use technology, because sometimes when you graph lines on a graph paper, you're going to get a janky decimal, okay? And so what I would say is get out your graphing calculator And I would suggest that you practice going to the y equals and plugging both those equations. Make sure you use a negative in front of the 2/3 on the first one and a subtraction sign in between before the two. So this has to be negative and this has to be subtract. Okay, so negative and subtract there. Graph them both. And then you're going to do, the steps are, so graph both. Then you're going to second, and you're going to do calculate, and you're going to find intersection. Okay, and then what you're going to do is you're going to say, okay, it'll say first curve. You're going to say yes, enter. It'll say second curve, and you'll say yes, enter, and then it'll say guess. If there's only one point of intersection, you can just push enter. If there's multiple, you have to arrow left or right to get closest to the one that you want, and then push enter. And it'll give you the ordered pair where they cross. So I'm going to write down the answers for these. This is what the first graph will look like right here. And you'll see the place where they intersect at the very bottom. Okay, so if you do it correctly, you'll see, let me see if I can make this bigger. You'll see at the bottom where these will be intersecting. And so the first one is going to be at negative 1.06. Oopsie, this is writing on. Negative 1.06 and then comma negative 1.29. It says round to the 100th. So this is the first answer to the question. The second one, you might want to get it into slope-intercept form before you do that. Now, I'm going to tell you, making fractions is not necessarily wonderful. It's helpful, but the way that you do it for letter B and letter C, okay, would be you subtract 2x. So you got 3y. Let me show you this. You get 3y is equal to negative 2x plus 18. Okay, and the thing is, you can divide each one by 3, or you can put a whole fraction with 3 on the bottom. So you can literally type in y is equal to that, just a single fraction, negative 2x plus 18 all over 3, and that's faster than doing multiple fractions if there's multiple fractions in a problem. So that may be helpful for that problem as well. And the second one, if you, again, because the numbers are not so lovely, you could minus 4x, and so then you would get y is equal to negative 4x plus 26 all over negative 5. And so you can type that in your calculator, and your answer to that problem is going to be 7.64, and then it's also going to be 0.91. I got 10 out of 11 because I had a fraction in there, but you can just do 10 divided by 11. It says round to the 100, so it'd be 0.91. I just did 10 divided by 11 on the basic key, okay? Especially this method would be helpful with this next question, because you're gonna minus 4.7x from both sides. You get y is equal to, so you minus 4.7, so negative 4.7x, and then plus 21.4, and then you divide both sides by a negative 7.2. So I'm going to just put over negative 7.2. Okay, so that's what you would type into y equals, and then also this one here. And if you find out where they cross, I'll give you the answer. So if you want to check it and see, I got 3.27 comma negative 0.84. So check it. If your calculator is saying really angry words at you, well, then maybe we should chat and be like, is it in a weird mode? Did somebody last year have it for like stats or something else where they put it in a weird mode for you, and I can get it out of there for you? And so, or maybe you're forgetting a certain button, or maybe you're interchanging the subtraction. Subtraction goes between values. Negative goes at the leading term of a problem. So we can talk about, why is it being so mean to you? The last one says, hey, use technology. And truthfully, you could just solve it. But one thing I want you to do, and this is kind of a weird concept, is if it says, hey, solve this. And sometimes you're going to have like weirdy equations. And I do this when it's like, you'll see like 5 square roots and a cube root and weirdy things. You're like, I don't know the math of how to solve it. So what I want you to teach you is your graphing calculator can solve it and give you a decimal answer, which is not always the best, but I'm going to tell you can do this. Okay, so the last part, again, if you've got an equation that's like, oh, I'm going to give you an example, like something like, square root of 3x, minus 5 to the second equals the cube root of 5x squared plus 7. And you're like, I don't know how to solve that. No, I really don't like it either. So the thing is this, because it's an equation and because your calculator does equations best when it graphs them, okay, you can pretend it's a system of equations. You can say, hey, I want these two things to be true to each other, kind of like a substitution type thing. And we can say, well, if I graph y equals the left side and y equals the right side, if you find out where those two graphs will cross, the x coordinate will be of the xy team. The x coordinate will be the solution to the problem. It's the weirdest thing. It's like doing substitution where you're like, okay, we're going to insert a y, pretend it's a system of equations, graph those two sides of the equation to see what x would be to make those equations equal. And so if you can plug in y equals this on the left side and y equals this on another line on this other side, and if you look to see where they cross, you're going to figure out what the solution is. You don't really care what the y is, okay? But the answer to this question is going to be 4.9. Because look at this picture down here on the left. It's going to be when y is 2.7. When these equations, the value that makes these equations true would be when x is 4.91, and then that would make them equations. They would both equal 2.7. So the y we just ignore because we don't really care. We falsely put it into an equation situation to say, hey, I can use this to solve for x. No, this equation here for number 4a is an easy one. You could just solve it normally. But I want you guys to realize if you graph each side of the equation, you can make it into a system of equations, and then the x coordinate is going to be the one that we want to have. And so x equaling 4.91 is approximately the solution to this problem. Okay, and you'd get the same answer if you solved this one algebraically, which you learned back in Algebra 1. Okay, the same with this. If you force this to be a system by graphing y equals the left side and y equals the right side, okay, you got two equations now, your calculator is best at solving things if it uses graphing. And so you're saying, okay, what x's will make this equation equal itself? Okay, like a substitution type problem. And so the answer for this one is x is equal to negative 2.91. Again, these ones are not that hard to solve normally, but there you will encounter weird ones of your life where honestly using technology is going to be awesome. All right, thank you. Have a good day.